Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Wafi Eusud, and this is the title for my journal, and this is my partner and my advisor. So the problem statement is that the project background is that electricity is heavily increasing year by year, and its generation is highly dependent on fossil fuels. Is always produce CO2 emission, which is not very good for the environment. So as a big result in this statement, we should really need to use solar system because the photovoltaic system has potential to design a future electrical system very clean and reliable and scalable, and it is high efficiency. PV create electricity from sunlight and transform into electrical energy, and this is why we have to create PV system, and it is very dependent on peak sun hours, pressure, and weather and others. So PV capacity, inverter, and load need to be sized precisely. So from that, we have to do a lot of computation sizing method and make it very complex. So we have to develop web application package and emphasize the PV system. And we go next to the objective. The objective is first we have to develop web application package and to develop Enphase. And next we have to go to novelty. Novelty is that first we have to use web application package and can size and predict PV system according to SEDA, and the specification of PV panel and interval can be determined. Costing load and will be provided, and Enphase calculation for operation will be developed. Then we go to the benefit society, user, and commercialization potential. Okay. For the benefit society is that we can reduce time to such PV system, and for the user, the mistake, be able to reduce the emission to environment, and the commercialization potential is we will upgrade the web application package for the industry beside for house and modify the user interface for friendly user purpose. And for the list of award is that this is the list of award, and my partner and I have participated in that. We have won gold and silver in national invention and also innovation poster. Okay, that's all for the content. Okay, for the next is that I will explain about this is the website, the interface of website grid connected to the photovoltaic system. It has the load consumption, photovoltaic sizing, tariff calculation and costing, total battery explanation. And we go to the next pages, which is the load consumption, and a manual guide for user is provided. And the user can easily key in their data, and total energy consumption in days and month will be provided also. So we go to the next page as well, and it has PV module and inverter explanation here, and also manual guide for user provided as well. So we will try put data in this, which is 345, 745, and 0.97, and next is 4. Then you will auto calculate like we can see here, and 3 seats, 0.36, and this is 2.5, and mismatch is 0.03, and maximum is 1100, and 0.93, and efficiency is 1. So average installation is 4. So we get the average daily energy production and also the monthly energy production. So we go to the next page, which is the tariff. So the tariff is that we have to calculate how much we have to buy. First, we have to put the value based on the calculated in the photovoltaic sizing, and put this, we have that monthly. So this is the expected bill and total monthly saving that we got. Then next for the costing, that will also have around like, just key in the data, and 4, we have needed 4 and 1,500. Okay, then labor 2,000, wiring you have 30%. So this is the total costing. Then we have to go to the last part, which is the actual monthly is that 186, and this is the 111 like previous step, and this is the total costing that we have calculated. So the total payback period is 7.7 years. That's all for the sizing.
Assalamualaikum warahmatullahi wabarakatuh. My name is Rauqah Binti of Razak, and I will do the simulation for Enphase power output prediction for photovoltaic system. Okay, for the first, we must have the desired parameters, and in my project, I use solar irradiation for the third input, ambient temperature for the second input, and the first input is for the PV rating. So we must divide the 70% from the whole data into the data train, and another 30% into the data test. So when we generate the FIS into this data, we can get the rule viewer like this, and then this rule viewer, by using the membership function of triangular, managed to get the almost accurate power output, same as the output from computational method. So as we can see, when we enter the all three inputs parameters in the row viewer, we managed to get 104 watt per hour for 104 watt for the power output, almost the same as the for output like computational method. So for another thing is to test the accuracy of the result, we can try to test the training data with the FIS output. So we can get this kind of graph which shows that the data for both training data and FIS output are almost the same. And the root mean square error or the average error for both data is between the value of 0.00032, which is the error, the produced error was a very lower in percentage, and this shows that NFIS configuration is in a great performance with higher accuracy. So I think that's all for my presentation. Thank you.